Hello everyone, Miss Meek here, and today we are going to be talking about algebraic relationships. Now this is going to be video number 1 of several videos about algebraic relationships, and today our video is going to focus on tables. Now these are not just any type of table, they are called an input-output table, where we're putting a number in and using a rule or a process to get out an answer. So let's kind of explore some of these tables here today. First of all, before we even get started with numbers, I want you to think about these tables like a machine. Think about an ice cream machine. So here on the screen you can see Miss Meek's ice cream machine. If I put strawberry flavoring, if I put strawberry flavoring into my machine, what's going to come out of the machine? Or what can you expect to come out of the machine? Is it going to be chocolate ice cream? Is it going to be vanilla? Is it going to be chocolate mixed with vanilla? No. If I put strawberry flavor into my ice cream machine, what's going to come out of my ice cream machine is going to be a strawberry ice cream cone. Okay, I'm not going to get chocolate or vanilla or blueberry or, any other flavor that you can come up with. It is going to be strawberry ice cream because what I plugged into the machine was strawberry flavoring. So if I put strawberry flavoring in the machine, I'm going to get out strawberry ice cream. Keep that idea in mind as we start talking about our tables. So instead of having a ice cream machine, we're going to have a math machine. And this math machine, its whole job is whatever number I put into it, it is going to add 3 to it. We can see that up here. This right here is called our rule. It is going to add 3 to it because that is the process that this machine does. And so whatever number I plug into the machine, so say I plug in a 7 into the machine, what's going to happen inside of the machine, it's going to do 7 plus 3, and then what's going to come out of the machine is our answer 10. That's how our tables are going to work. So I'm going to plug a number into our machine. We're going to do some math to it, whether it's adding, multiplying, subtracting, dividing, whatever it is, whatever our rule or our process is, and it's going to take a number out. It's going to kick a number out to us. That is going to be our answer. That's going to be called our output. Now, what's really cool about this is that our input and our output have different names. So the number that we plug into the machine is called the input. It is also called the independent quantity. So again, easy to remember, a lot of ins there, okay? Independent. The number that gets spit out of the machine, our answer, is called the output. It is also called the dependent quantity. Now what's really cool about that is the dependent quantity depends on what you put in the machine. So if I put in strawberry flavoring into my ice cream machine, that is going to determine what type of ice cream I get. And so that is why our answer, our output, is also the dependent quantity, because that number depends on what is put into the machine. So what I plug into the machine is called the independent quantity. What comes out of the machine that depends on that independent quantity is called the dependent quantity, or the output. Now you may have noticed that we use this letter X right here, okay? Don't get stressed out by that. That X stands for the number that we're plugging into the machine. And remember, that number can be anything. I used a 7 in this example, but it could have been a 10, it could have been a 0, it could have been a 1 million, okay? All that X stands for is a number that we just don't know yet. Okay, and it's that we are trying to we're going to plug something in and figure it out. So let's go ahead and take away all of the machines and actually look at a table. This is what the math looks like. So this is our table. Here in the middle, we have our process, otherwise known as our rule. And so these numbers here are the numbers that we're going to plug. If I could spell plug, that would be super helpful. We're going to plug into the machine. And when we do that, it's going to spit out our answer, and that's going to go over here in this column where the outputs are. So let's go ahead. Now this process, our rule for this table is 2 times x, meaning that all of these numbers here, these are our x's, we're going to multiply them all times 2. And in that middle column there is where I'm going to show my work. So 2 times 0 is 0. So it's going to spit out that answer of 0. Next one, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And then 2 times 4 is 8. So again, they could have put any number over here in this input column, and I know in this table what I have to do to it, multiply it times 2, and that is going to give me my output, my answer. So again, I put all of these x's here into the machine. Okay, I put all of these x's here into the machine, and they spit out these answers here. That is what we are doing here in this. Let's do another one. So in this table, our rule or our process here, our rule is everything that gets plugged into this table is going to have 12 added to it. So again, we're going to take these x's here and we are going to plug them in, add 12 to them, and it's going to spit out our dependent or our answer here. So let's go ahead and do that. So again, this middle column is for us to show our work. So 0 plus 12 is 12. 1 plus 12 is 13. 2 plus 12 is 14. 3 plus 12 is 15. And then 4 plus 12 is 16. So again, I plugged these guys in for this x right here, added 12, and then it puts out the answers over here. Now, one more thing that you need to know about is what if they make me work backwards? So instead of giving me the inputs, they give me the outputs, and they want me to work backwards and figure out what numbers are supposed to go in this column. All right, so let's take a look at what we can do. We have the process here. We have the rule. The rule for this table is these x's here are going to be minus 5, and when I do that, they equal these numbers in the output column. So what we have to do is we have to work backwards. We are going to work backwards. And the way that we're going to work backwards is I am going to do the inverse operation. Inverse means opposite operation. So everything, in order to get this column here, everything is subtracting 5. So in order for me to work backwards to get that column, I have to do the opposite of subtracting 5. I am going to have to add 5 to get the inputs. And so that is what I'm going to do over here. I'm going to add 5 to all of these numbers. And that is going to tell me the number that I plugged into the machine in order to get these outputs over here. So let's go ahead. That is not 10, sorry. Let's go ahead and check our work here and see if our strategy of doing the opposite operation worked. So if I put a 10 over here, let's see, 10 minus 5, is that 5? Yes. Okay, 13 minus 5, is that equal 8? Yes. 15 minus 5, does that equal 10? Yes. And then 17 was our other one. 17 minus 5, does that equal 12? Yes, it does. So when they give me the outputs and they say, okay, work backwards and figure out what numbers are you plugging into the table, what numbers are you plugging into your math machine here, you do the opposite operation. So if you have to work backwards, you use the opposite operation, which would be to add 5. All right, guys, this is the first step in starting to learn algebraic relationships. You got to be able to understand tables because tables are your best friend when it comes to algebra. And hopefully you will be seeing that in the next several videos as we talk more about algebraic relationships. All right, I will be talking to you later. Bye.